Good morning, class. Let's continue our next topic, specific heat capacities of gases. What is the heat? As you all know, heat is the energy which is exchanged between two things. One is system and another one is surrounding. Exchange of heat is possible only when there is a temperature difference. Okay? Heat is transfer in one form of energy to another form. What is the symbol about heat? It is Q, capital Q. Units of energy is joule. Common unit is calorie. 1 calorie is equal to 4.182 joule. It is the relation between 1 calorie and joule. If we give heat to the system, then the system is positive. If we take heat from the system and give to surrounding, if we heat is given by the system, then the heat is taken as negative. Now what is specific heat? Dear students, specific heat is the amount of heat transfer. To raise amount of heat transfer, let Q is amount of heat transfer. To raise the temperature del T for m number of moles. Clear? How much heat is required to raise the temperature? This one for this number of moles. Clear? Specific heat is denoted by C. In case of isothermal process, as you all know, temperature remains same. There is no temperature difference if del T is 0. Temperature is constant. If temperature is constant, then the difference between temperature is also 0. If this one is 0, denominator is 0, then what about whole expression? If denominator is 0, then the specific heat capacity is infinite. If we talk about adiabatic process, in case of adiabatic process, amount of heat is 0. There is no exchange of heat in case of adiabatic process. As you all know, there is no heat of transfer. That's why Q is equal to 0. If Q is 0, then C adiabatic. Specific heat for adiabatic process is 0. Now, specific heat capacity at constant volume. If we talk about at constant volume, then the amount of heat required to raise the temperature del T for m number of molecules. Clear? For constant volume, we denote Cv. For constant pressure, we denote it Cp. Q is equal to Cv if we have 1 gram number of moles and del T, then the temperature difference is 1 degree Celsius. If this one is unit, then the specific heat is equal to H. Clear? What is the unit of specific heat? Joule per gram degree Celsius. Similarly, in this case, when the Q is Cp, if 1 gram of moles are there and then temperature difference is, we have to increase the temperature 1 degree Celsius. Now switch to molar specific heat capacities of gases. What is molar specific heat capacity? This is amount of heat required to raise the temperature of 1 mole of a gas. How much moles? 1 mole of a gas by 1 degree Celsius. This is called, students, molar specific heat. Molar specific heat capacity at constant volume is equal to Cv is equal to Q and del T. Here Q denotes how much amount of heat required to raise the temperature del T for n number of moles. For Cp it is Q by n del T. Example, you have oxygen gas, O2 gas. In this case, specific heat, simple specific capacity is X. Let it is X. For 1 gram of O2 to raise the temperature of 1 degree Celsius, amount of heat required is Cv, molar specific heat, and that is equal to m, mass of the oxygen gas, cross atomic mass cross Cv. Simple specific heat capacity. The specific heat capacity is X. Clear? For molar specific heat capacity, you have to multiply it. Simple specific heat capacity multiply by atomic mass. Clear? Similarly, for molar specific heat capacity at constant pressure, we have mCp. Here, small cp denotes specific heat capacity, and capital Cp or Cv denote molar specific heat capacity at constant volume and constant pressure. Remember, there is one important relation between molar specific heat capacity at constant volume and at constant pressure. This is Cp minus Cv is equal to R, where R is gas constant for any gas. Clear, dear students? Now, one numerical for this relation. For N2, the value of Cp minus Cv is N2. For nitrogen gas, let calculate Cp minus Cv is equal to R, as we all know. Here Cp is molar specific heat and it is equal to atomic mass cross Cp specific heat capacity minus Cv. What is the mass of nitrogen? 28. Take it common and divide it by R. R by 28. Option 4th is correct. Clear, dear students? Please make notes for this topic, and if you have any query then please ask from me. Thank you and have a nice day, dear students.